Welcome back. In this video, we're going to solve absolute value inequalities. And we're going to take what we learned from union and intersection, or and or, and we're going to apply that to absolute value. Recall from earlier in the year, we defined absolute value. Absolute value is the distance between the graph of a number and the origin on a number line. Now we're going to see that our origin is not always going to be 0. Okay, you learned in grade school that it was always from 0. Well, that's not always going to be the case. But hopefully when you see absolute value, I want you to think distance. It's distance from some particular origin. So here are 3 absolute values. The absolute value of x equals 3. So we're saying that our distance from the origin is exactly 3 units away. So distance is exactly 3 units from the origin. Okay? And in this case, the origin is 0, because this is going to be x plus 0 or x minus 0. Okay? In the second example, the absolute value of x is greater than 3. That means the distance is greater than 3 units away. So we're going to have some particular origin, and we're going to go 1, 2, 3 units, and all the distances that are more than 3 to the right, and 1, 2, 3 units to the left, and head off to the left. Okay. And finally, less than, the distance, the absolute value, some absolute value is less than 3. Well, that's less than, or we could do less than or equal to as well, just like we could do greater than or equal to. But the distance is less than or equal to 3 units. So if we have some origin, okay, some point, and then we're going to go, 1, 2, 3, and 1, 2, 3. But if we want them less than 3 units away, that graph is going to look something like that. The red is all the points that are less than 3 units away from whatever our origin is. Okay? So some more definition. Conjunction. A conjunction is and. Okay? So when you see and or you see conjunction, think intersection here. Okay? What's common to both, or overlap, really. Think overlap. Okay? Both algebraic sentences must be true here. And situation occurs when we're working with less than or less than and equal to. So we might have some standard form here of an absolute value, a minus b, or we'll have x and some numbers in here, is less than c. So our distance is less than something. So if our distance is less than, this is going to be an and problem, less than. I've written this way intentionally. So we need to know that less than is an and problem. And I'll show you why in just a minute. Disjunction is an or problem. Think union here. So an or problem is union. At least one of the sentences must be true. Either or. Okay? Well, if the distance is greater than, absolute value is greater than or equal to, the distance is greater, it's an or problem. Okay? So if we have the distance is greater than, it's an or problem. If distance is less than, it's an and problem. And equals to, we saw equals at the beginning. Equal is equivalent to a disjunction, so equals is also or. And it'll be good for you to have that in your notes. So here's our process for solving inequalities. When we solve inequalities, what we want to do first is we want to isolate the absolute value bars. we want to clear everything away from the absolute value. So we'll use reverse order of operations to clear everything away from the absolute value bars. So if we had something like 2 minus 3 times the absolute value of x minus 5 is greater than 12, something like that, we would want to clear all of this, the 2 away. We would want to subtract 2 from both sides. Then we'd want to divide by negative 3. Essentially, we want to strip everything away from the absolute value bars, so we get the absolute value of x minus 5 is less than, what is that going to be? Negative 10/3, I think that is. Okay, but we want to clear everything away from the absolute value bars. Okay, so watch out when you multiply or divide by a -1. You have to change the direction of your inequality, which I did here. So essentially what you hear me talk about is strip first. Clear everything away so that there's nothing hanging on to the absolute value bars. Second thing you want to do is determine if it's a conjunction, an and problem, or a disjunction, an or problem. Okay, so this particular one here, it's less than, it's an and problem. Okay, so if we have the distance is less than or equal to, it's and if we have greater than or equal to, greater, it's or. And see how I've written this. We can remember less than is and greater, spelled G-R-E-A-T-O-R, tells us that this is an or problem. Then, once we have stripped everything away, we want to rewrite our expression as 2 algebraic expressions, equations, inequalities. I probably should use this inequalities here. As 2 algebraic inequalities linked with and or. So in my little sample up here, we would have x minus 5 is less than negative 10/3. And we said this was an and x minus 5. Okay. In the second expression or inequality, we would drop the absolute value bars again, so no absolute value bars. We'd flip the inequality symbol. It was originally less than, now it's going to be greater than. And then we make c, or our negative 10/3, the opposite sign of negative 10/3, positive 10/3. Okay? So this is the kind of thing we would do. Drop the absolute value bars and keep everything the same. Okay? As I've done right here. And in the second expression, linked with our and, drop the absolute value bars, flip the direction of the inequality, and take the opposite sign. So we would solve both of these expressions for the unknown. We'd continue to carry the and all the way down with us until the end. And then we would solve, we'll graph, and then we'll interpret our graphical solution and make a final answer. So let's go ahead and do some sample problems. Let's start with the absolute value of x plus 7 equals 2. Okay. Well, everything is cleared away from the absolute value bars, so this one's going to be a little bit easier for us. Okay, so we will drop the absolute value bars and keep everything the same. So our first equation is x plus 7 equals 2. And since this is equals, we said this was a disjunction, so we'll use or. Then we drop the absolute value bars again. We flip the direction of our equal sign, which is still an equal sign, and take the opposite sign and get negative 2. And then we solve each. So I subtract 7 from both sides. I get x equals negative 5, or, and I subtract 7 again, and x equals negative 9. So x can be negative 5, or x can be negative 9. So graphically, we can just plot our critical points, and x equals 5, and x equals 9, and there is our final solution. Let's take a look at sample problem B. Sample B, a little bit more challenging. We've got some stuff we have to get rid of here. So we have to clean everything away from the absolute value bar. So I'm going to subtract 11 from both sides. So I get 2 times the absolute value of 3x minus 7 is greater than or equal to 8. And then I will divide by 2. I get 3x minus 7. Pardon me, the absolute value of 3x minus 7 is greater than or equal to 4. Our distance is greater than, so this is going to be an OR problem. I drop the absolute value bars. I keep everything the same, so I have 3x minus 7 is greater than or equal to 4. Or I drop the absolute value bars, flip the direction of my inequality, and take the opposite sign. So 2 problems I have to simplify. So I will go ahead and do that. I will add 7 to both sides. I get 3x is greater than or equal to 11. Divide by 3. I get x is greater than or equal to 11 thirds. Or I will add 7 to both sides again. I get 3x is less than or equal to positive 3. I divide by 3, and I get x is less than or equal to 1. So x is greater than or equal to 11 thirds, or x is less than or equal to 1. So I need all the points that are greater than or equal to 11 thirds and less than or equal to 1. So my 11 thirds and my 1, and I want all the points it's equals to, so I'll use the bracket. I want all the points that are greater than or equal to 11 thirds. So that's all those points. And all the points that are less than or equal to 1. So I do a bracket because I want to include 1. And I head off in the negative direction. And then finally, in interval notation, my final solution goes from negative infinity to 1, and I'm including 1, union with 11 thirds all the way to positive infinity. So that is our final solution. And in sample problem C, again, I've got some stuff hanging on here, so I'm going to clean my absolute value bars. I'm going to subtract 21 from both sides. I get negative 4 times the absolute value of 2 minus 5x is greater than negative 2. I divide by negative 4. I'm not going to distribute in. I caution you against that. Let's just divide by negative and clear everything away. And we get the absolute value of 2 minus 5x. Now, since I divided by a negative, I've got to flip the direction of my inequality. And negative 2 divided by 4 is 1/2. So the absolute value of 2 minus 5x is less than 1/2. So since it's less than, this is an AND problem. And I'm left with, so I drop my absolute value bars. 2 minus 5x is less than 1/2. And 2 minus 5x. Drop the absolute value bars. I flip the direction of my inequality. I take the opposite sign, and I get negative 1/2. So now I've got these 2 different problems to simplify. And I will carry down. I'll get x is less than or greater than something. Here I think I'm going to get x is greater than something. And here I will get x is less than something connected with this and. I will leave the rest of this for you to finish and bring this to class, and I will see you in class. That wraps up our lesson on solving absolute value inequalities.